accelerator at Arab Bank. I hope everyone is staying safe and well. Thank you for joining our webinar session. In today's webinar session, we will be discussing about AI in fintech, touching upon lending and payments. Our speaker today is Gregory LaBlanc. He is a professor at Berkeley, and I'll leave the longer introduction for Gregory. Today's session will be run over 1 hour, in which we'll be diving deeper into the AI in the fintech industry, talking about lending and payments. And then in the last part of the session, we'll have a 5 to 10 minute Q&A on the topic. So on that, I'd like to pass it on to Gregory. Gregory, it's a pleasure on having you here. Please share your screen and take this forward.
Thank you, Faisal. Can you see my screen?
Yes.
Okay, excellent. So I'm just going to do a very quick survey of artificial intelligence, machine learning, and data science with applications in banking and finance. So I have to say that for those of you who are not super familiar with the terminology, data science, machine learning, artificial intelligence, they all have slightly different meanings, but they overlap in some very important ways. And so I'm going to kind of use them interchangeably in the sense that these are all tools that help you and help your organization to make better decisions. Okay, and if you think of it that way, then it becomes a little bit less kind of mystical. It becomes a little bit less arcane. It becomes a little bit less exotic, because all it is a tool that helps managers to make better decisions. Okay, so I'm going to start off by just introducing myself real briefly. I teach at UC Berkeley. I teach in the business school. I also teach in the engineering school. I teach courses on fintech. I teach courses on data science, digital transformation, blockchain, lots of topics related to finance. I also teach at HEC Paris in Paris, and I got most of my training at the Wharton School, and I've taught at some other economics departments as well here in the US. I've also taught at a lot of different companies. I've done some training and consulting, lots of banks, lots of financial institutions. Now, when I talk about banking, and I've been teaching about banking for 30 years now, I always like to start with this picture of the Girard Bank over here on the left of your screen. Now, this is a bank that's located in Philadelphia, and it was founded in the 1830s, and it was founded by the richest man in America at the time. And the reason why this bank looks the way it does, and I don't know, I was in Jordan last summer. I didn't have the opportunity to go to a bank when I was there, but when they build these banks, they want to make them look real solid. They want them to be all permanent. They look like if you put your money there, it's going to be there in 100 years. And then when I came out to the West Coast, I had a similar experience with Wells Fargo Bank. Very imposing building, very solid, meant to convey the message that the bank will be there in 100 years. Okay, but there's another institution which also looked very imposing and which we thought would be around forever, and that's the bookstore. Now, the bookstore, as you all know, is disappearing, and it's pretty hard to find a bookstore here in the United States because it's been replaced by Amazon. And the question is, will banks go the way of our bookstores? And as you can see here, it says on the border store, final days. And if you go back and you look at this bank on the left, you will see luggage carts. That's because it is no longer a bank, it is a hotel. And indeed, the book industry has disappeared, and the banking industry is under threat. We see the amount of investment that is plowed into fintech startups here in the United States and around the world. This is about $20 billion, $31 billion of deals on a quarterly basis. Okay, this is amazing. This is a massive, massive amount of investment. Now, this is dwarfed by the amount of investment that's made by the legacy banks on their own IT infrastructures. So if you go to a bank like JP Morgan Chase, they have like a $20 billion annual IT budget. So for those of you who are counting, that's a lot of money. Okay, they're really becoming software companies with a banking license. You actually hear the general, you hear Goldman Sachs CEO said that recently. We are a software company with a banking license. And indeed, if you look at a typical bank, like Wells Fargo, every single functionality that they perform on their website is being challenged. It's under attack by fintech startups. Okay, so these big old beasts lumbering down the savannah are being attacked by the small, nimble hyenas. Okay, and what makes these little hyenas so much more nimble? Well, it's primarily their use of data and their use of software. So at a bank like Wells Fargo, I would guess that maybe 1 or 2% of the employees are software engineers. If you look at a bank like Chime, which is the fastest growing bank in America, has no branches, and it's about 60% software engineers, software developers in terms of the employee base. So I'm going to walk through what the World Economic Forum calls the wheel of disruption in finance. I'm going to focus on just the 2 sectors that we mentioned at the top, and I'm going to talk about how AI and machine learning are disrupting these 2 parts of the financial ecosystem. Okay, so, and when I talk about data science, I actually teach a whole course on data science for executives, where in a few short weeks I get the executives up to speed so that they can play around with data, use some of these super easy off-the-shelf Excel, like actually easier than Excel, like data science tools. I always start with this guy right here. This guy is a local hero here in the United States. He is the manager of our local sports team. Not the sport that you guys are familiar with, but with baseball. And this guy, Billy Bean, as general manager of our local Oakland Athletics baseball team, completely and fundamentally transformed the sport of baseball, sports in general, and business in general. And his story is told in this book called Moneyball and this movie called Moneyball. I highly recommend you watch this movie. It is more entertaining, and you'll learn a whole lot more than you will with me in 1 hour about how data can transform business. Now, what did this guy do? Remember, this guy had no training. He was not a statistician. He was not a data scientist. He hired data scientists and statisticians. In fact, he hired people that knew nothing whatsoever about baseball to come in and make the decisions. What he did was replace the old, experienced people who made their decisions primarily by gut with young, tech-savvy, data-savvy people who made decisions using statistics. Okay, so the area where he made the biggest impact initially was in HR. Now, HR is not on the list here, right? We're talking about lending and we're talking about payments, but data science is super powerful in the area of HR. So, for instance, people, when they would evaluate a player coming in the door, they would look at this player up and down, and they would say, this player reminds me of a player that we had 10 years ago who was really good. Or this player reminds me of a player who was bad 10 years ago. In other words, these guys would do pattern recognition in their head. Now, this is actually kind of the way in which lending is being done at most big banks, right? At least historically. They would look at a borrower and they would say, this looks like the kind of borrower who repays their loans. This looks like the kind of borrower who doesn't repay their loans. And so rather than relying on that human carbon-based pattern recognition, all we're doing is replacing it with silicon-based pattern recognition. And that's because it's a lot more accurate. It makes better decisions. So for instance, in the movie, there's a scene about these scouts who evaluate a player by saying, his girlfriend is not attractive, therefore he can't possibly be a good player. Right? Now, look, is this right? I mean, is this true? We don't know. Like, no one's ever done any kind of testing of that hypothesis. Okay, and so what they were able to do is generate outperformance entirely based on their HR analytics. So as you can see here, this team, this local team from the city of Oakland with not a lot of money, was able to compete against the New York team and the Los Angeles team, even though those other teams had 3 times the budget, right? So in today's world, the little guy, the scrappy guy, can come in and play head to head against the bigger, better capitalized player if they are smart enough to use these new tools like analytics. Okay, now, just to continue the HR story, I have some friends who started a company about 12 years ago. And the premise of the company was, how do we get our employees to stay on the job longer? Our call center employees, how do we get them to stay on the job longer? Okay, now they bounced around a whole bunch of ideas, and ultimately they realized that it doesn't matter if you have good ideas if you don't have any way to test those good ideas. And so what they did is they went to a company, they asked for the HR data, they added all that HR data into a database where the final item in the database was how long did the player and how long did the employee stay with the company? And all they were doing was looking for, right, characteristics or attributes of the employee that correlated with long-term employment. And once those patterns popped out of the data, this company, all they had to do was change their hiring practices towards those people who they predicted would stay on the job longer. And so by doubling the amount of time that people stay on the job from 6 months to 12 months on average, they doubled the ROI of their entire HR department. And so I believe that every company can go through every single vertical, HR, operations, finance, marketing, and identify opportunities for improvement simply by applying the kind of machine learning tools that anybody can learn in just a few hours. And that's why we now talk about the Moneyball of marketing, Moneyball of sports, Moneyball of lending, Moneyball of finance, Moneyball of marketing. Now, here's how it works. So I'm going to give you data science in a nutshell. It's really not that complicated. All you need, here it is, all you need is a spreadsheet. Okay, so you've all worked with spreadsheets, right? If you haven't worked with spreadsheets, give me a call. We'll sit down, we'll hang out, we'll talk about spreadsheets. Okay, everybody's seen a spreadsheet. If you have a spreadsheet, you can do data science. In fact, if you've ever done a regression, you've done data science. So what we want to do is we want to organize all of our data into rows and columns. Now, rows are individuals, right? Columns are features. We call them features instead of variables. So for instance, if you were trying to figure out who to hire, okay, every employee is a row, and every characteristic of that employee, you know, their age, their education, their experience, their previous job history, is a feature, okay? If I'm trying to figure out whether or not to make a loan to you as an individual, right, you're going to be a row, every applicant's a row, and every column is a feature, okay? So if I have historical data, I need to have historical data, which we call our training data. If I have this historical data, all I have to do is feed it into one of these models, and what it'll do is it'll spit out, right, a prediction about a new individual that we haven't seen yet. Okay, so if I want to predict whether you're going to default, I look at all my previous customers to see who defaulted. If I want to see if you're going to click on an ad, all I have to do is look at all my previous customers to see who clicked on ads. If I want to see if you're going to be a good employee, all I have to do is go back and look at my historical data and figure out who were the good employees. Okay, so here it is, boils down to 2 words. And after this hour, when you go back to work tomorrow and somebody asks you, what did you learn in your 1-hour video? And those of you who are not paying attention, who are texting right now, you can stop texting just for this 1 minute, because I'm going to tell you the secret to data science in a nutshell. And that is 2 words, training and scoring. Training and scoring. If you understand training and scoring, you understand machine learning. That's all it is. So by training, what do we mean? Well, these algorithms, okay, and there's a whole bunch of them to choose from. The simplest ones include logistic regression, let's say, right, or nearest neighbor, or naive Bayes, or decision trees. You don't need to worry about that. But you take these very basic algorithms, and in their raw form, they have no structure, okay? They're like a little baby coming out of the womb, doesn't know how to walk. And what you do is you feed that baby experience. And as you feed that baby experience, the baby knows how to walk. You take those algorithms and you feed them your training data, and it will spit out a scoring model. So, you know, credit score is probably the most common, right, form of scoring model, right? So if I inject all my previous borrower history, then it'll spit out a score for any new borrower, right? Really quite simple. This is the kind of thing that should be going on right now in our coronavirus situation with respect to potential patients, right? It's not being done very well, and in part because the data is not being collected in a form that can be injected into these models. Okay, so if you don't have your training data, then you can't have a scoring model. It's really very simple, which is going to mean whoever collects the data is in a position to develop the model. Okay, so as a business, I'm jumping the gun here in case somebody has to leave early. Whoever has the most data is going to win. Okay, if you collect data and you use it, you're better off than someone who is flying blind. Okay, so as a large bank, you have a lot of data. It's all about figuring out how to mine that data, find the insight in that data, develop scoring models. Okay, so here's an example of what we call a decision tree scoring model. Okay, and here's an example of a logistic regression scoring model. And I call them scoring models, and really what they're doing is they're doing some kind of classification. So they're creating some classification boundary, basically saying people on the top to the left of this line are the ones that are most likely to default, and the ones that are on the right-hand side of the line are the ones that are most likely to repay. Okay, and then we can adjust the sensitivity depending on how comfortable we are with someone's probability of defaulting. Okay, and so any one of these models is going to create what we call a confusion matrix. And I'm throwing some terminology at you, right? But for those of us who have been following the whole coronavirus situation and we're looking at these antibody tests and so forth, you're aware that there are two ways that you can make a mistake with one of these classification models. One is to have a false positive and one is to have a false negative. Okay, now just that little insight right there is why business people tend to interpret data science models better than data scientists. Okay, I'm going to say that again, because I think most companies think, oh, I got to hire some data scientists. And you're absolutely right. Like if you don't have a data science team, you are dead. Okay, you're dead. It's that simple. You're dead if you don't have a data science team. Since I started teaching this stuff 10 years ago, I would meet people at fairly large companies and I would say, how many people do you have on your data science team? And someone would be like, well, we don't have any data scientists. I'm like, all right, you're dead. That's simple. You don't have data scientists, you're dead. However, if you don't have some grown-ups in the room supervising those data scientists, you're also dead, right? The data scientists work for the business people. It's not the other way around. And that's because data scientists, they're amazing at finding patterns in data. I mean, they're amazing, but they don't always know what kind of patterns they should be looking for, right? They don't always know, right, what the business is interested in. They don't know, like, what are we trying to do here, right? When I do these classes where I have data scientists and MBAs in the same room, data scientists are like, oh, this is so cool. Look at this. Wow, check this out. And you're like, what are you doing? Like, what does that have to do with making money? Like nothing. So stop doing that and come on over here and do this. Okay. And so when a data scientist is developing a model, oftentimes what they focus on is accuracy. They're like, hey, let's come up with the most accurate model. Okay. And they define accuracy as the smallest number of errors, smallest number of mistakes. And you might think, well, that sounds great. Like if I'm developing an antibody test for the coronavirus, the best test is always going to be the one that has the fewest mistakes. No, that's not true. That's not the best model. The best model gets the right kind of mistakes. Okay. So for instance, this is a case that happened a few years ago with the central bank of Bangladesh, right? So some North Korean hackers went in and they siphoned off about $100 million with a fraudulent transaction. So if you were the data scientist in charge of kind of flagging fraud, and you had this wonderful model, you had all this training data, and you had to decide, like, where do you draw the line, right? And when I say where do you draw the line, that's like, where do you draw the decision boundary, where on one side you reject the transactions, and on the other side you accept the transactions. Now, if we have in our training data over here, two-dimensional training data, and so that means we want to carve a line, right, in this space, we have all of these blue dots, which represent legitimate transactions, and all of these red crosses, which represent fraudulent transactions. Where would we draw the line? Okay, where would we draw the line? Now, you could draw them in such a way as to catch those two fraudulent transactions. And indeed, I think that's what, as a business person, I would want to do, right? You want to catch the fraud, okay? If it's big fraud, if it's like $100 million fraud, you want to catch it. But a data scientist would look at that and say, hey, we're making 4 mistakes. There's 4 false positives. Whereas if we move that line over to the blue line, we'll only have 2 mistakes, false negatives, okay? And so if you treat a false positive and a false negative identically, then you will wind up with a lot of big fat fraudulent events, okay? So that's the kind of thing that where, you know, the common sense of a business person can come in and guide the data scientist. So part of what I teach with my companies that I work with is not just like, you know, how does data science work, but how do you put in practice, right, a decision-making system that flags the kind of mistakes that your company is likely to make, right? It's all about the workflow. It's all about who has the right to make the decisions, what kind of information are they getting, and what kind of assistance are they getting from this tool, right, which is designed to make the decisions better, not worse. Okay, so here's an example, and again, this is like, you can leave after this slide if you're really interested in just the data science piece. This is a slide which shows what we call a profit curve. This is the end goal of any data science model. This is like, if you can get, and this is usually what I do at the end of my class, like after 6 weeks, we're like, all right, boom, now you can create profit curves. This is what you're all after. And so what this profit curve is showing you is the difference between using a targeted advertising model and a random advertising model, right? So when we launch an advertising campaign, suppose we have, you know, we want to promote mortgages. Okay, so we're going to buy some ad space in Facebook, buy some Google ads, right, for mortgages, for people in Amman, let's say. Now, we could just sort of randomly just spray ads out there and see what happens. If we do that, we're going to lose a lot of money. As you can see, the more people we advertise to, the more money we lose. This diagonal line here is essentially how much money we lose by advertising at random, because you don't want to show a mortgage ad to people who aren't buying houses, right? Now, if we can go through all of our customer base, right, by analyzing the checking data that we have and all the personal data that we have, and we rank order people from most likely to convert to least likely to convert, and we start advertising to the people at the top and then work our way down, there's going to be a point where it's just simply not worth it to advertise to that person. Okay, and so what we can do is increase our profits by advertising to more and more people until we hit a point where the cost outweighs the benefit, and so we stop advertising to them. Okay, and so here what this graphic shows you is we can try out a couple different classifiers. So I mentioned a few, like nearest neighbor, right? Logistic regression. We can just try them out. And this is what data scientists do. They just do trial and error, try a bunch of these algorithms, figure out which one works. And here it looks like classifier 3 is the best one, and it tells us, right, where to advertise and to whom. Now this, I hate to comment on coronavirus, but this is exactly what our data scientists in public health should be doing. And we have about 6 months of data. And so we should be able to take every single individual on the planet and give them a risk score, right? So if you're 80 years old and you have cancer and diabetes, okay, you're much more likely to die than if you're a 4-year-old in kindergarten in perfect health, okay? And so, we could target our healthcare expenditures, right, by starting at the top and protecting those, starting at the bottom and infecting those, and ultimately, tackle this problem at a tiny fraction of the cost that we're spending right now. Okay, so what we need is more data scientists in healthcare, just like we do in finance. Okay, so I'll tell you just a quick story, and it's about this bank called Cigna Bank. So Cigna Bank was the 340th largest bank in the United States. That's why you've never heard of them. 340th largest bank in the United States. Never heard of them. And so how did this little tiny bank based out of Maryland go from being the 340th largest bank in America to being the #1 credit card issuer in the world. How did they do it? Well, you guessed it. I can't hear your response, but if you're not screaming, if you're not at home yelling at the camera, yelling at your computer, the words data science, machine learning, and artificial intelligence, then you have not been paying attention for the last 28 minutes. Because what they did is they looked out there and they said, every bank in America is lending to the same people, right? Every person at the top with a high FICO score, high credit score, is getting like 10 offers for credit cards. And all the people at the bottom are not getting credit cards. And so they said, we think that among that group of people below some threshold, they probably have some good credit risks. Since every single bank uses the same credit scoring model, we think that we can come up with a new credit scoring model that identifies the good credit risks in the pile of rejects from our competitors. Okay, now how would you do this? So just think about this. How would you do this? How would you evaluate the creditworthiness of people who have never borrowed money, right? The unbanked people. Well, the only way to do it is to actually lend the money. And so what Cigna Bank did, what Capital One did, was they sent out credit cards to all these people, to people who had never had credit cards before. In fact, I remember my dog got a credit card back in the 90s from Capital One. My dog got a credit card. Okay, so they sent all this before KYC, right? Obviously, right? They sent the dog thing out, and of course, what happened was most of these people, they defaulted. Most of them defaulted because most of them were, in fact, bad credit risks. Okay, I mean, banks aren't stupid. They didn't want to lend to these people. But at the end of 6 months, even though Wall Street was yelling at them, shareholders were yelling at them, everyone thought these bankers were crazy. At the end of 6 months, they had a huge pile of red ink, huge pile of losses. But they also found a few gems, a few diamonds in that pile of garbage. Okay? And so what they did was they canceled the credit cards of all the defaulters and they continued to lend money to the winners. But that wouldn't be enough to make up their losses. What they did was they went into that data and they very carefully analyzed it, looked for patterns, and they identified what made those repayers different, right? What were the characteristics that made them different? Because when they sent out those credit cards, they sent them out to people on whom they had a lot of data, okay? And so even though they lost a lot of money, you shouldn't think of that as a loan loss. You should think of it as R&D. Think of it as R&D, because that data set, they were able to amortize the insight from that data set for 20 years. Okay, and furthermore, all the other banks were at a disadvantage because they didn't have that data set. Okay, they had proprietary first-party customer data. This is the gold that everyone is looking for. Proprietary first-party customer data. If you have first-party customer data, meaning you have direct interaction with the customer and you can collect data from that customer, you are golden. Okay, and banks are in a unique position because banks have a ton of first-party customer data. Okay, they know deposits, they know withdrawals, they know who you're writing checks to, they know who you're charging credit card statements to, everything. They have all this information. They have your monthly deposit of your paycheck. They have your monthly mortgage payment. Okay, they're sitting on a massive pile of data. In fact, you have all these fintech startups swirling around and they're nibbling at the heels of the banks because they have software engineers, software developers, data scientists, no legacy architecture. They're all cloud-based, right? They're nimble, they're agile, okay? They use, lean methodology. They do sprints. They have all the modern stuff. And that's why they're running circles around the big banks. But the one thing they don't have, and the one thing that you have, is data. 10 years, 20 years, 30 years, 40 years worth of data. And they would kill for your data. And if they got their hands on your data, then you're dead. Okay? So your data can save you if you have the right people and the right tools to utilize that data. Okay. And so all of these new startups, what they're doing is they're looking at alternative data. They're looking at information that the banks don't look at. Okay. So for instance, there's a company called Earnest. It was founded by a guy I know, went to Harvard Business School. And when he graduated Harvard Business School, he applied for a car loan and he didn't get it because his credit score was based on prior borrowing, not future income. So he thought this was insane. So he started his own bank. That's what you do in America. If you run into a problem, you just start a company to fix it. And so what he would do is he would look at, what school did you go to, right? What degree did you get? That kind of thing, right? Which is more predictive of future repayment than your prior repayment. One of my students who's from Korea, she came to America, came to Berkeley, and she was paying her tuition with cash, and she couldn't get a credit card. So what she did was, when she graduated, she started a credit card company. Okay, I'm an advisor to that credit card company, and they just started business like 6 months ago, and they already have thousands of credit cards. And who do they give credit cards to? Immigrant children in America who are attending universities and who have good credit, even though they are good credit risks, even though they have no credit history in America. And what she does is she looks at other data. She looks at your Facebook data, looks at your LinkedIn data, your Instagram data, right? There's so many other sources of information that you can use, okay? And so all these peer-to-peer lenders that you've heard about, rather than thinking of them as peer-to-peer lenders, because they're not, they get their money from institutions, you should think of them as algorithmic lenders, because they're using machine learning to make the lending decisions rather than a loan officer, okay? So just to give you an example of the kind of data that you could be using to evaluate a credit risk for a customer, what about things like location data? All right, location data. So if you know nothing else about me, I don't exist to you, I have no credit history, what could you do? Well, if you have access to my phone, you can track my whereabouts 24/7, right? Almost every single app on your phone is tracking your whereabouts. So this is just from Facebook. So Facebook knows where you are. They know where you are right now. They know what you're doing right now. They know everything. And so this is actually just one day in my life from my Facebook account. And you can go into your Facebook account, you can see where you've been. Okay, so this says a typical day in the life of me. I leave work and it knows that it's work. They see me driving. This is the Bay Area. They see me driving. I should have grabbed a picture of my time in Amman and shown you where I was in Amman. I mean all the usual spots for a tourist, right? But here I am going down, and I'm spending a couple hours at LinkedIn headquarters, and then I head up to Google headquarters where I have lunch, and then I head up to Facebook headquarters. Now, if you're a bank and you're looking at this and you're like, this person's spending a couple hours, at each of these places. That's interesting, right? In fact, not only can you tell where they are, like Facebook headquarters, you can tell who this person's meeting with. So if they're having a meeting with Dave Marcus, right, head of the Libra project or something like that, that's more, interesting than if they're in the parking lot, hanging out, getting a picture in front of the big thumb, okay? So we know a lot about this person. Then we see that this person, after 5 o'clock, went to this place called K&L Wine Merchant. Whoa, hold on a second. Is that a good thing or a bad thing? I don't know. But we could go through our data and say, hey, people who drink wine, are they good or are they bad, right? That's a feature we could have in our model. And then we see this guy heads up to the Opera House and spends 4 hours in the Opera House. Good feature, bad feature, I don't know. We could run some analysis, right? And ultimately, if we collect along this one day, we have collected already more data points than exists in a typical FICO score. Okay? There is so much data just in this location. And so a lot of startups are doing this in emerging markets. So here's a company called Tella. And what they do is they operate in Kenya, Philippines, Mexico, other places. And for people who have no credit history, no employment history, no rent history, right? They might even have a birth record. They can apply for credit. And all they need to do is download the app and then allow the app to explore what's going on in the phone. Okay, so for instance, what apps do you use? Do you use gaming apps? Do you use productivity apps? Okay, they know. Where do you spend your time? Are you going to the same place every day, 9 a.m. to 5 p.m.? Okay, they know. Do you spend time in the casinos or the bars? They know. Who are your contacts? They know, right? What's the content of your messages? They know. Okay, they know all this stuff. In fact, I heard from a fintech entrepreneur in China that one of the features that turns out to be extremely predictive in a lending model is, how does this person use their battery? Do they allow their battery to go all the way down to 0, or do they start recharging when it goes down to 20%? If you're the kind of person who recharges your battery, then you're also the kind of person who is likely to repay your loans. Okay, super interesting, super interesting. Not the kind of thing that a typical bank would have looked into, because what data science does is, on the one hand, it allows you to interrogate the data and ask very specific questions of the data and get answers in the data. But there's an entirely other piece of data science, which is called data-driven discovery, where you let the data speak to you, right? You let the data tell you what's going on. So I doubt there was anybody at this company that said, hey, I got an idea. Let's look at battery life. I got a hypothesis around battery life. Now, what they did is they took all the data that they hoovered up from this phone database. They just pushed one of these buttons, like a decision tree, and the decision tree just went tick, 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 tick. Here are the features that matter. So that HR startup that I told you about, that was identifying call center employees to figure out which ones make better call center employees. Well, it turns out that one of the most predictive features in your job application was not what school did you go to, not how many years of experience do you have, not your age, but what browser do you use? What? You're going to make a hire? You're going to hire an employee based on what browser they applied for the job using? Yes, that's what machine learning can do. You have all your prejudices, you have your biases, you think you know how to identify a good employee by reading their CV and saying, well, looks like they went to this university. No, sometimes your decisions are based on myths and false assumptions. You need to let the data tell you what makes for a good decision. So in psychology, we talk about the big 5 personality. And the way to figure out somebody's personality is to ask them this very long questionnaire. But it's actually quite a bit easier just to look at their Facebook profile. And by analyzing their likes, we can tell what kind of person they are. In fact, we can tell what kind of person somebody is more accurately than their coworkers, their friends, their roommates, right? Pretty much everybody but their spouse. Facebook knows you better than pretty much everybody but your spouse. And that's, of course, why we had that scandal, right, called Cambridge Analytica, because Facebook knows you so well, they know what type of ads to put in your newsfeed. Okay? Now, how do you take advantage of this sort of thing? Again, by collecting proprietary data. This is a peer-to-peer lender that's active here in the US. It's called Prosper. Now, when they first started out, they would ask potential loan applicants to write an essay, And that essay would be, why do you want a loan? And tell us a bit about yourself. And so people would write this little essay saying, here's why I need the money, here's who I am, here, whatever. And so after observing these borrowers for years and seeing who repaid, who didn't repay, the folks at Prosper teamed up with some academics, and they took a look at these essays, and they tried to figure out, does the content of the essay predict repayment? Now, they used a very simple technique called naive Bayes, which is also used for spam filters, and they just looked at the words. So take a look at these words and tell me which of these words in this essay correlate with repayment, which correlates with repayment. Okay, so mentally take note, say which one do you think correlates with repayment? These are users in the United States. Okay, well, turns out these words correlate with repayment. The other words actually negatively correlate with repayment. So if somebody writes an essay where they say, I promise I will repay you after I get out of the hospital, so help me God. Don't lend to that person. Okay, that person is probably not going to repay you. Okay, again, counterintuitive, but again, the data speaks. And if you wanted to make use of this data, it would be very difficult because you are not Prosper. Prosper is the only company that has this kind of data, and they've been collecting it for 5 years. If you start collecting this data on your applications today, it'll take you a long time to catch up to Prosper. Okay, now one final point I'll make about this data science here is, once you have carved out a competitive advantage from the use of analytics, the use of machine learning, the use of data science, can you expect that advantage to be sustained over time? And the answer is no. The answer is no. Because if we look at what happened with our friend at the Oakland baseball team, they went right back to being average, right back to being average. And the reason for that is that their competitors imitated them, copied what they were doing, and hired away all of their people. So if you are expecting to develop a competitive advantage based on analytics, you can't. All you can do is get to that baseline where everybody is expected to be in today's world. The only way you can gain a sustainable competitive advantage is through the collection of data that no one else has, and then the application of analytics. And this is why Facebook and Google give away their analytics, but they don't give away their data. Okay, so in today's world, entire businesses are built on collecting unique data streams. So we have this company here in the US called Square. Now Square is a wonderful company. It's now worth nearly $10 billion. And all they did, their business idea was very simple. They realized that there were a lot of people, like street vendors and restaurants, that would only accept cash. And this was a big inconvenience for them because most people like to use credit cards. And so they provided these vendors with a little dongle, which converted a smartphone into a POS system. Very, very simple, right? One of the beautiful things about APIs, you just can build a business like this overnight. Now, how do they make money? You're probably wondering, how do they make money? How did they become worth $8 billion? And you might think, well, they make money from these transaction fees. And you'd be completely wrong. They lose money on every single transaction. They lose money on every single transaction. And so then how do they make money? From the data that they collect, right? They know things about these merchants that no one else knows. So if one of these merchants walks into a bank to borrow money to build out their falafel stand, right? The bank's going to turn them away. You guys are going to turn them away. You guys are going to say, no way, get out of here. Where's your collateral? Where's your business history, right? If it's cash based. But when they go to Square, Square will give them a loan because Square has data that no one else has. They have data that no one else has. Here's another company which is in the news quite a bit. It's a company that sells connected thermometers. So when you take your temperature, that data goes into the cloud. Now you're thinking, what? Like, wait, why? Right? How do they make money? They make money by selling that data to the pharmacies. So the pharmacies know where people are sick, okay? And they can rush in flu medicine into the areas where people are sick. Right now, right, in the United States, they use this data to move ventilators and other kinds of medical equipment to areas where they are needed, okay? So it gives you advance warning of where the surges are gonna be in the hospitals, okay? So I usually, at this point in my class, I ask people, right, a quiz. And the question is, in autonomous driving, we have two car companies. We have Google and we have Tesla. And we want to know which one of these is winning the war for autonomous vehicles. And most of my students will say Google, because they'll say, oh yeah, they have better data scientists. They have better machine learning. They're huge. They've been doing it for a long time. They've got all this great stuff. And I say to them, yes, but how much data do they actually have? Right? They don't actually have any cars on the road. They have just a couple of these cars on the road. Whereas Tesla they collect more data every day than Google has collected in its entire history related to cars. And so if data science is about training and scoring, first you need your good data scientists, and then secondly, you need to have your good data. Okay? Okay, so I'm gonna skip ahead. There's a lot more stuff here. And I just wanna highlight, and if I had to end the course, and I usually end my data science course with this slide, Mark Andreessen famously said, software is eating the world. Every company is becoming a software company. And I think that's true. But I also like to say that data is eating the world. And so every company has to be a data company. If you're not a data company, you are a dead company. It's that simple. You can have your regulated industry, you can have your bank license, you can have your government protection, but at the end of the day, sooner or later, someone's gonna figure out how to put you out of business if they can master data and software better than you, okay? Okay, so I'm gonna skip ahead. There's so many other examples that I could give you about automation and about machine learning, but I just wanna highlight that when it comes to capturing data, one of the most important ways to capture data is through payments. Okay, let me skip through the payments, okay? Okay, this is all about investments, okay, and wealth management. We can talk about that. Key thing, know your customer. I remember Moses came down from the mountain with the 10 tablets. In fact, I think this was in Jordan. I was there at Moses' mountain just this past summer. And when he came down with those tablets, right, they had 10 commandments. And the 10 commandments of business, they're all the same. Know your customer times 10, okay? And so just a few words on payments. We all know now that payments are going mobile. So we've got Google Pay, we've got Apple Pay. We've even got Starbucks Pay, which in the US is the #1 mobile payment app, believe it or not. And so why are these payment apps so interesting? Well, in part because they collect all this data. When I walk into a store and I swipe my credit card and I purchase, let's say I go into a butcher and I buy some beef, okay? Well, that information, the butcher has that information, right? The issuing bank has that information, right? The accepting bank has that information. The payment processor, Visa or MasterCard, they have this bank, they have this information. If you think about Amazon, Amazon issues credit cards, they have this information. And so, who has this information and what they can do with it is the battle that every company is fighting right now, right? The battle is who can access the most data so they can make the better decisions, okay? And so we all know that the US is way behind in mobile payments, and the leader is, of course, China. And so with Alipay and WeChat, with Alipay and WeChat Pay, these folks use a closed loop system, just like PayPal used to, which keeps all of the information in-house. And this is why these two companies know more about everybody in China than any company outside of China could ever even fantasize about, right? Because, and that's why when the Chinese launched their test and tracking system, it was relatively easy because every single person in China has one of these two, if not both of these apps. And so what we're seeing is a move towards these alternative payment systems, which are much, much cheaper. Now, the reason why this kind of payment system didn't take off in the US is because in the US, everybody has a credit card. But in countries where not everybody has a credit card, right, these types of closed loop systems and mobile payment systems have an opportunity to take over. Now, the reason why I mention this is because what WeChat and Ali were able to do, once they were able to insert themselves into the payment process, now with all that data they collect from the buyers and from the sellers, this opens up a Pandora's box of opportunity, because now they can start lending to the buyers, lending to the sellers, managing the cash of both of them, right? Funneling that cash into investment products. They are now truly financial superstores. And if I were to invest in any financial institution in China, it would be Ant Financial, right? And that indeed is where I have invested, right? Is with Alibaba, right? That is the strongest financial institution in China. The banks, those banks are, they're all defaulting. They're all going bankrupt without government bailouts. But these two companies are not, because they use real data, real-time data. They're not looking at your credit history. They're looking at what you're doing right now to evaluate your credit worthiness. And we're seeing that happen in the US. Amazon is moving into banking. They're moving into finance. Apple's moving into finance. I now have my Apple Pay with my Apple Card. Okay. Google's moving into payments. One of my students is heading up Google Pay. One of my students is heading up Amazon's payment systems. And of course, Facebook, as we know, is moving into payments, right? Not just with Libra, but with WhatsApp Pay. And so we're entering into an era where the players aren't just going to be these little fintech scrappy startups, not just two dudes with a laptop trying to create a company to disrupt banking. Now we have to worry about the big players, the Googles, the Facebooks, the Amazons, right? The Ollie's, the Tencents. Indeed, they are disrupting the world of payments, and by getting their fingers on the payment interface, they're able to ingest the data, which they can use for training and scoring and for lending. Okay, so anyway, that was just meant to be like a little bit of a intro to machine learning, and I think we can stop here. We have time for a couple questions. Thank you. Faisal.
Great, Gregory. Thank you very much. So we have a couple of questions. The first question is, how will AI handle a new type of data that is coming out of COVID-19?
Yes, so specifically related to COVID-19, we see policymakers right now making a lot of decisions, and those decisions are based on various hunches. They're based on various simulations and models that are built on a whole bunch of assumptions. Okay, and so what we'll be doing over time is replacing those assumptions with data. Okay, so we have assumptions, for instance, about the infectiousness of the virus that are very rough and ready and just grabbed out of the thin air. Now what we'll be able to do is we'll be able to, as I mentioned, rank order people in terms of their vulnerabilities. In addition, we'll be able to identify exactly what treatment paths are optimal for which people. For instance, there are multiple different mutations of the COVID-19 virus that are in circulation. We should be able to identify which ones are more virulent, which ones are less virulent. We also think that viral load might be a factor in terms of severity. So as we start collecting more and more data, we can figure out, make predictions that are much, much more accurate as a function of different policy interventions. Now, this will only happen if people are collecting the right data. And up until now, I would say that we have done a terrible job of collecting the right data. So if we go back to that HR example, if I never asked any of these employees any questions when they were hired, then I wouldn't be able to go back and analyze the relationships within the data. And so, when patients come into the hospital with exhibiting various symptoms, what we don't do is we don't systematically ask them a bunch of questions, like, what are all your conditions? What is your experience? Like, what have you done, et cetera, et cetera, et cetera, so that we can throw that all into a gigantic spreadsheet and analyze it. We don't actually, take a look at the virus to figure out what strain of virus they have. And so we can't put that into a spreadsheet and analyze the data. We're not actually testing in a systematic way. We're just testing whoever shows up with symptoms. And that's why we don't really understand, the conditional fatality rate. And so, if what you do is you approach this as a scientific issue with a very, very clear idea of what kind of data you need to collect in order to make decisions going forward, then we can make much, much, much better decisions. But if we're just flying blind and relying on our gut instinct, then we're going to make some pretty bad decisions, both at the hospital level, but also at the governmental level.
Mm-hmm. Another question in terms of COVID-19. So for the lending solutions and the lending algorithms that have been built on different data sets, how do they basically rebalance their data sets going forward as consumer behavior starts to change?
Yeah, this is a great question. So the question relates to what we call drift, right? So what happens with drift is, and I skipped over some slides related to this. Our training data is a living, breathing thing, and so if we don't have closed loop reoptimization where we update our data set in real time, then what we'll be doing is making decisions based on like old data. Okay, and so part of the art of data science is figuring out, like, should we be using the data from the last year, the last 10 years, the last 20 years, right? Because as behavior changes, the relevance of that previous data becomes less and less. So for instance, and this is particularly the way I think you should approach, if I was analyzing this virus, is to analyze it the way we analyze cybersecurity. So cybersecurity is one of the biggest use cases for data science within an organization, because every organization is under continuous attack, right, from hackers, and it's an arms race. It's a chicken and egg game, because the hackers are using data science, and the security people inside the organization are using data science, and the attack surface is huge, right? So one of the most famous cases in the U.S. of hack was Target, the department store. Their credit card database, all their customers' credit card, was sitting in what they believed to be a very secure part of their servers. What happened was somebody just hacked into their HVAC system, like their air conditioning system. So in the building, they had an air conditioning system, which was being run automatically, using some software. And, they didn't really have a lot of security around the air conditioning system, because, I mean, who wants to hack into air conditioning? But the air conditioning system was connected to, right, the security servers, because it was, regulating the load of the air conditioning based on the compute. And so once you hack into one piece, you can make your way all over to the other pieces. So when you're looking for spam, or you're looking for fraudulent transactions, if you're relying on what was considered spam 10 years ago, or what was considered fraud 10 years ago, then you're going to wind up making some really bad decisions. Mm-hmm. Okay. Now, of course, what happens is, as you move forward and start adapting to the current fraud, and you start ignoring the old types of fraud, those old types of fraud start working again. So I recently went to hospital a couple of years ago. I was in France, and I went to the hospital, and I had an infection from skiing on my leg, and they gave me a antibiotic from the 1950s. And I was like, wait, this is like an antibiotic from the 1950s. And they're like, oh yeah, it works again. Right? It didn't work. Now it works again because people stopped using the antibiotic from the 50s. They all started using cutting edge antibiotics. Now those don't work. And so now the antibiotics from the 50s work. So your data science model has to be a living, breathing thing where you're updating your data continuously. Okay, and I think that, you know, if we have access to your movement data, for instance, you know, we know when you're staying at home because you're sick. We know, and I skipped over all this stuff about health insurance, but all the health insurance companies now are interested in tracking your movement, you know, your step data, your heart rate data. They're interested in, you know, figuring out like, hey, are you engaging in activities that are likely to lead to sickness? So for instance, right now, if you're supposed to be sheltering in place, but in fact, you're running around, you know, partying and hanging out, well, you know, your phone data will pick that up, and maybe your insurance company, if they're tapped into that, might like send you a text and say, hey, you got to stop, you know, running around. And of course, you know, that's not entirely accurate because all it means is like you can run around without your phone, right? So I have a great picture of somebody in here who was, I have some friends, I know people like to smoke their cigarettes in Jordan, and I have some friends who like to smoke their cigarettes, and they signed up for one of these healthcare plans where they, you know, where they attach the Fitbit to the healthcare system so they could get rewarded for their exercise. And so what this guy does is he puts the Fitbit on his dog, and he lets the dog run around. So I do think that, you know, if you, because small businesses, I mean, in the US, we are seeing all the restaurants are going bankrupt. All the barbershops are going bankrupt. All of the small, you know, service companies, service businesses are going bankrupt. And, you know, if I have access to real-time customer, if I know what your turnover is, I know what your average bank balances are, I know all this stuff because I'm your bank, then I can tell, you know, who's at risk. And, you know, if it comes to the government dispensing aid or emergency loans, if they partner with the banks are the ones that know exactly like who's at the greatest risk and who should be getting the aid. In fact, that's not what's happening here in the US. What's happening in the US is whoever has the best lawyers who can help them fill out all these crazy forms, they're the ones that are getting the aid rather than the people that need it the most. And so, you know, a bank could be very useful in this respect because they have access to, you know, monthly churn, monthly cash flow, all that kind of stuff, as long as that entity is part of the banking sector. We all know that you know, a lot of business is done in cash and it's invisible. And so the banks don't know, the IRS doesn't know. In those cases, you know, there's not much you can do to help them because they are withholding that data. So one of the reasons why I buy all my books from Amazon, and one of the reasons why I never use cash, is because I want Amazon to know all my book purchases. I want my bank to know all my purchases because I want my bank, the better it knows me, the more likely it is to help me. I recently refinanced my mortgage to get a lower rate. It went from 4% down to 3%. And, you know, it was the most painless process ever. I didn't have to do anything. I called my banker and I said, hey, I want to refinance. And she was like, well, you know, you do all your banking with us. You know, if you buy like a 15-cent pack of gum, you do it with my credit card. So like we know how much money you make, and we know how you spend it. And so here's your refinance. Luckily, I got it right before my income, you know, was cut in half by coronavirus. But hey, it worked out.
Next question is, why aren't CEOs and global leaders using more data science to manage their business or nations?
Oh, it's very simple. Nobody, you know, what got you to the top isn't what keeps you at the top, right? The way you got to the top was using certain types of, you know, methodologies, using certain types of information, When the world changes, nobody wants to change, because it would be moving into a world where the things you're good at aren't necessarily the things that are good in the new world. So what I find is that leaders consistently resist change. They consistently resist, innovation. This is the biggest stumbling block to corporate survival. I like to say, when you look at companies like Blockbuster, and you look at companies like, iHeartRadio here in the U.S., when you look at companies, like Sears or Toys R Us, all of which went bankrupt, they didn't go bankrupt because they had bad managers. In fact, they had amazing managers. They had great managers. These managers were the best managers around, right, in those organizations. That's why they got to the top, and they were doing amazing job running these companies using old management techniques, right? And they optimized inventory. They did all this great stuff, but what they didn't do is they didn't understand how to manage for the new environment. So disruption in general of any kind, not just using new tools like data science, machine learning, but understanding new business models, understanding when the business landscape has changed, understanding that you've got entirely new groups of customers, understanding that you have to move into the cloud. So whether it's understanding you need to hire new types of people, all those things are scary, and and it's just human nature. I'm in a university. I remember when I launched the first data science class at UC Berkeley for our business school. There was a huge amount of resistance from the faculty, because the faculty were like, "Wait, what are you talking about? Data science? Like, you want us to have data science classes? You mean we have to learn Python? We have to learn R? We have to learn whatever? And we know Excel. Excel's what we grew up with." And they resisted it, and it takes like 7 or 8 years to produce new PhDs. So the universities are super slow. So the companies that are able to kind of bake in continuous innovation and create a culture where experimentation and trying out new things is rewarded, rather than frowned upon, those are the ones that'll stay relevant.
Mm-hmm. So the next question we have, and we actually have two similar questions on data privacy and ethics.
Yeah.
So how do we balance and avoid regular regulation breaches, but as well, how do we maintain the ethics?
This is a huge question. So look, there are certain situations where the proper the proper use of data lines up with profitability. So when we think about things like bias, right, where in the U.S. it's a huge issue, is where the different groups of people are treated differently because of bias. Well, here's a situation where when you eliminate that bias, you make better decisions and you make more money. Okay, so there it's the companies have an incentive to eliminate those ethical issues, ethical problems. Where it gets a little trickier is, when you're using this super fine-grained personal data to make decisions. Now, I think even then, in most cases, the interests of the customer and the interests of the company are in alignment, right? So the more Google knows about me, the more relevant the search results will be. The more Facebook knows about me, the more relevant the ads will be. The more YouTube knows about me and Netflix knows about me, the more relevant the recommendations will be. With Amazon, the more relevant, and like, I want more relevant recommendations. So I'm perfectly willing to give Amazon and Google and Facebook like all my data. Similarly in healthcare, right? When you go into a doctor, if the doctor knows your smoking history, they know your exercise history, they know all this stuff, they can do a much better job as a doctor, okay, and give you better recommendations. Now, there are going to be situations where, like in the medical situation, this might mean some people wind up getting, their insurance canceled. And that's going to be something what, you have to have some kind of regulation in order to, provide some kind of safety net for people. I think most people would agree. Where that happens at what level is up to the society. Another example of this has to do with, when these companies manipulate you to do things against your best interest. So whether it's advertising like products that are addictive, casinos in the U.S. Manipulate their customers to make them lose more money than they would otherwise. And we saw in the political system where you manipulate people into voting certain ways. I think rather than focusing on the data, which is what we've been focusing on, protecting the data, I do think we should spend more attention on regulating what can be done with the data, right? Because the problem isn't the data. The problem is what people can do with it. And so we think, oh, if we just safeguard the data and lock it up, then that'll prevent the bad things. But then it also prevents the good things. And we're seeing that right now in the US. We have this law called HIPAA, which designed to protect the privacy of our health data. And it's creating a absolute disaster because the health officials can't figure out, they're trying to figure out, hey, who dies and who doesn't die. And the only way to do that is to see your electronic medical records. And if we can't see your electronic medical records, we don't know your prior conditions. How are we supposed to design this filtration model, right, where we can rank order people and figure out what their real risks are? So, if we're up to me, I would be like, hey, you want my healthcare data? Here it is. I just throw it into the system, let everybody use it, because that's how you get better systems. As long as the people who use it are regulated. And so in the US, the banks are regulated, fintechs are not. And so the fintechs can do all sorts of things that the banks can't do. But even the fintechs in the US cannot, discriminate based on gender, based on race, and so forth. So they actually collect that data, but they're not allowed to use it. And I will say this, if you have a explicit data science model that has race and sex and health history and all that, all you have to do to not use it is delete them. Very simple. But if a human is making the decisions and you tell the human, hey, don't factor in religion, that human will be like, oh yeah, I'm not gonna, no, I won't factor in religion. But in reality, there's no way that a human can just delete something that they already know. And so that's why when companies use algorithms, instead of relying on humans, it's much easier to regulate what they're doing, because it's hard to regulate what happens in somebody's head, but it's very easy to regulate what happens inside software.
Mm-hmm. So the last question we have here is on the unstructured data. So going back to the example that you gave in terms of the battery life, what other alternative data sources could be useful to look at if it's from demographic or behavioral or biometric data?
Yeah, so specifically for things like, credit risk, it's really wide open what kinds of things we think might matter for things like credit risk. You mentioned, biometric data. Chinese are now, facial recognition. Obviously, they're doing a lot on facial recognition, some of which was a little bit scary. But if we could understand, for instance, your mood or your affect, and if we could see, how happy you are and how unhappy you are, this actually could be super interesting. If we can measure the way you move, there's so much information in terms of the way you move, in terms of the way you type. So I have a friend at PayPal who is in charge of security there, and what they actually do for their fraud models, which are incredibly sophisticated. One of the inputs is how you type your password, right? So it's not just about getting your password right; it's about how do you type it, right? What's the speed with which you type it? Okay, how does the thumb move around on the screen? How does the mouse move on the screen? That information is super important. Facebook has developed a way they can tell, whether or not you're likely to commit suicide based on your posts, right? There are, I have a friend who has a company. They can tell whether or not you have liver disease based on how your eyes track a dot on a screen. Okay, so these correlations that no one had ever thought about before are starting to pop up. In the retail environment, which is an area I work with a lot, I work with a lot of bricks and mortar stores. They use beacons to track the movement of the people inside the store. Like, how do you enter the store? When you enter the store, do you turn right? Do you turn left, right? Which aisles do you go down? How fast and how slow do you move up and down those aisles? All of that can be, interpreted, managed, and used to predict, right, what people are likely to buy. So, really, it's just so wide open, the kinds of information that we collect about people, or can collect about people. And I'm sure we will be discovering these correlations, which no one had ever thought about before. Particularly, like, with autonomous driving, we're just picking up so much information that we can use to enhance the driving process.
And I'm sure with these current times, as people move more and more to digital channels, there's more data that's being created, where that opens another opportunity for that data to actually being used. On that note, Gregory, I'd like to thank you very much for this insightful session on data science and AI, where we went in more deeper sense in terms of looking at lending and payments. And I'd like to thank everyone for tuning in this session. And I hope everyone stays safe and well. And thank you very much.
Okay, thank you, Faisal.
Thank you.